Okay, so we're recording again now. And let's see, we got 7 students this time. So good morning, everyone. Thanks for tuning in. So let's see here. Let's do a little survey. If you go down to the bottom of your window, over to the right, there's something reactions. You have 2 options. You can like applaud. Feel free to applaud for me anytime you like. I always appreciate that. But let's use the hands up. If you've submitted your observations, go ahead and put the thumbs up.
Okay. Where is that?
Oh, it's at the bottom. You go to the bottom of the screen where the share screen is and all that stuff in the chat.
Oh, okay.
There's a little smiley face with the plus called reactions. So like.
Oh, yeah. I saw it.
Like I said, my observation. Okay, so the 2 professors here, we've done our jobs. We got the thumbs up. So the rest of you, we want to get you to thumbs up today. And so a couple things. Let's see, I'm going to open the chat window. And we mentioned this last time, but I just want to really drive home what's available. And I'm going to walk you through it, but it's also all here. Let me give you the link. I was going to go through the second week stuff today, but I think since no one submitted yet, I'll just go through. All right, I'm Dan Reichert. I'm sorry, that was the video actually playing. Okay, so in the chat window off on the side, if you don't see it, go ahead and open up your chat window. Again, the button's at the bottom. You go to the bottom and hover, and the options come up, and you can bring up the chat window. There's a link. Is that to the playlist? Yeah, I think that's to the list. So this is a list of video tutorials. The first one's a little bit lengthy because it's explaining all of Skynet. It's a lot of the stuff I went through last time. Can I go over how to do each problem in WebAssign? Yeah, but first we have to collect data. And so we're going to go through how to collect the data in some detail today. You know, I went through it kind of generally last time, but I'm going to walk you through it, and I'm going to have you do it now. We'll pull up Skynet, and we'll all go through it together. And then next week, we'll come back, and we'll delay the due date of this again. Even if lab 1's the only one we get through, hopefully we'll get through like 2 labs anyway.
Yeah, 2 labs, hopefully,
yeah. I want to get through at least one of them really well.
Yeah.
And the first one is critical because you can't do the others without really understanding how to use Skynet, how to use Afterglow. And so we all got to put our observations in to get started. Okay, and so that playlist is basically a better version of what you're going to see today. It's good that you're listening today. We're going to walk through it today, but you can always go back and play those videos for detailed instructions on what to do, what everything is, and how it all works. And I'll just share my screen. And let's see, that's the lab. Put that back up in a second. And just give me a second to readjust this on my other screen so I can see as many of you as possible. There we go. And okay, so when you click that link in the chat, which, so I cannot see the chat when I'm sharing for whatever reason, but whatever, I'll check it later. That will take you here. It's a playlist, and it has 3 videos. The first one's how to submit an optical observation to Skynet. The second one is how to check and resubmit optical observations. And the third one is how to observe the moon with Skynet. We're going to focus primarily on this first one right now and make sure you get your observations in. But I'm not going to play it. I'm just going to go through it. So let's see. Here we are over in Skynet. When you log into Skynet, as we talked about last time, it takes you to this page. You have to type in your credentials. But I presume everyone has an account now. And we went through that last time. Give me a thumbs up if you have your Skynet account set up. Give me, okay, there's one. 2. Give me a clap if you have not set up. So a thumbs up if you set up your account, and a clap if you have not set up your account. That way I can tell. So I got 1, 2, 3, 4, 5 thumbs up and 2 abstentions. So I'm going to assume you all have Skynet accounts. There's a bug on my computer. Get out of here. Okay. Now I'm going to assume you all have Skynet accounts. If you don't, you received an email from Skynet about 2 weeks ago, maybe about 1.5 weeks ago. And dig through your emails and find that and just follow the instructions. And you'll have your Skynet account and you'll have the time, about 30 minutes of observing time, which you may not realize it, but that's a valuable resource. Professionals, to gain access to these telescopes, they pay $75 an hour. And so every single person in the class got half an hour. So that adds up to, you know, a pretty valuable resource. And we're just donating that at Skynet. That kind of comes with the WebAssign lab. Okay, so then you get in here, and we're going to put in an optical observation. But let me bring the lab over here for a second. And so I talked about this in some detail last time. I'm not going to go through it in great detail again. These videos here, the first 3 are the 3 that I just gave you the link for, so you actually don't need that link. They're right here at the bottom. And the other videos are for the second week of the lab, once you actually have observations. And there are other instructions here in bold. It's worth reading that stuff. Things like don't have 2 WebAssign tabs open at the same time. You can lose your answers. How to format scientific notation, things like that. These are the same in every lab, so I'd read it once to make sure you understand it. And then you come down here and you see we have 2 weeks, week 1 and week 2. I was going to go through week 2, but since most of you haven't put your observations in yet, we're going to focus here in week 1. And let's see, I lost Dr. Zhang, but that's okay. I'll carry on. And you can see we have a goals section, tells you what we're hoping to accomplish in this lab. An equipment section, telling you about what you need, and here you just need a connection to the internet. Some background sections that I went through last time that I'm not going to go through again, but please feel free to read through them at least once, telling you about the telescopes we have available to us in normal times. Because of the virus, most of our telescopes are shut down now. Not because there's a problem with the telescope, but just if we can't send someone out to fix things if they break, we shut down before it breaks. And a lot of people are, quarantined at home. There are do not travel orders. These telescopes are all around the world. Each country has different things going on. So a lot of our scopes and our best scopes are shut down right now, which is unfortunate. But there's still a few, and so we'll try to get some observations with those. And then you get down into the procedure section, and this is how to put in the observations. There's a section here, how to observe with Skynet. And there are links, like a link to a video tutorial. This is an old version. These videos I put at the top are the new version. So instead of using these embedded video tutorials, just come up here and use these new ones. WebAssign is going to switch them out soon, but they just haven't done it yet. So how to submit an observation, it's right here. This is an old version. And in fact, we've done a full update of this lab. It just hasn't been processed by WebAssign yet. So as a PDF, Dr. Zhang is going to send you that PDF that has all the updates and revisions. And you may want to go through that one. You can still submit your answers here, but slightly better explanations, and the software has changed. And so the text is more relevant to the new software. This is about 5 years old now, and software changes pretty quickly. At least our software does. Anyway, this tells you how to do an optical observation, but really, you just have to watch the video here. And again, I'm going to walk you through it today. This is how to check your images. But again, you can just watch the video here, how to check your images. And then we get down into the observing planets, observing moons, observing dwarf planets, observing deep sky objects. So observing planets. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. Those are the targets. This is telling us what filter is best for that target. Some of them are going to use a U-band filter. And we mentioned this last time, since we don't have too many telescopes, instead of U-band, I recommend that you use the low-through filter. More telescopes have low-through filters than just U-band. And then V-band, which is a pretty common filter. U is like ultraviolet, and low-through is anything that blocks most of the light because these are bright targets. V means the middle of the visible band, so lots of telescopes have those. And this is how long to observe. So let's go through some of these. We're going to skip over Mercury. Mercury is always too close to the sun. I've removed it from the new version of the lab. So we go to My Observatory, Optical Observing, and we're going to add a new observation. That's the second one over here on the list. And we're going to go through each planet. I'm going to put in the full spread during this video con. So we're going to check Venus first. Now, we don't need these advanced settings. Down here, you should have -12, 20, and 0.5. And so you want to check that each time. Make sure it's -12, 20, and 0.5. That gives you the best chance of seeing your target. And then once you've typed those things in, you can go down to this air mass chart. And as long as the lines are above the gray line, that means the object is observable. Basically, I have access to all sorts of observatories. You do as well. Let's see, one that's still open is Midris. And that's kind of one of the golden curves. And so you can see for maybe about an hour, the beginning of the night, Venus is observable before it sets. Venus is always close to the sun, so you have a short window. As long as it's above the gray line on at least one of the sites we have access to, that means it's observable sometime over the next 24 hours. So in that case, we'll continue. And you press the filters button next. And the lab manual says U-band. So again, since we're running short of telescopes, we're going to just use the low-through. Here under generic filters, you select low-through. Because again, these telescopes are black and white cameras. And there's a wheel with different colors of glass. And here we're selecting what piece of glass to put in front of the camera. And low-through is something that will let some light through, but block most of the light. Because again, these are really bright targets. Venus is right now, I think, the brightest thing in the sky to the human eye. These are super sensitive telescopes. All we really want is a little bit of light to come through. So I pick low through, and when I did that, you can see it blocked some of the telescopes. Some of the telescopes do not have any low through filter, but many of them still do. So we're going to continue, save and continue. And actually, let me just pop back for a second here. Let's make sure nothing else is selected. Because that can really limit us even more. Okay, I don't think anything else is selected. So going forward again. Now we're going to select our telescopes. And we can see all sorts of telescopes here. But again, many of them are shut down because of the virus. So what you want to do is come over to your time account on the right. Let's see, I have 4 different time accounts, but you probably only have the one. And it gives a list of what telescopes you have access to. Just press that orange button. And I hope you're following along at home. If not, you can pick up on the next one. Press that orange button, and it will select all available telescopes that you have access to. Save and continue. And now we're going to put our observation in. And first you pick a design telescope. Each telescope is completely different. Some you need to observe longer, some you have to observe shorter. instead of putting in different lengths of exposure for each telescope, we've simplified it. You pick one telescope that you design on. Now it's like generic 16-inch. It's the same as the Prompt 5 telescope in Chile, but I just select generic 16-inch. Then you look at your table here, and basically you're going to put in one exposure of the suggested duration, 0.03 seconds. So we have our low through filter, one exposure, 0.03 seconds. And you can see if I put my cursor over any of the other telescopes, sometimes that leads to a different exposure, sometimes longer, sometimes shorter. It's because each telescope's different. It's adjusting the exposure time, so you get approximately the same result. Once you've done that, just check one exposure, save and continue. We have this review screen. You submit it, and it's in the system. It won't be observed immediately. It'll be observed as soon as the next available telescope can get to it. Let's do the next one. And is everyone going to try this at home? Are you trying it, or are you about to try it? If so, give me a thumbs up. Okay, good. Good. Okay. So let's just walk through them all then. I know it's tedious and repetitive with the instructions, but let's just get them all in the system. If you're doing it at home, by the time we're done, we'll get everything in. And not all these plants are going to be observable. So, probably only half of these will actually go through it all. So let's see. Back to optical observing. And just to point out, right now it just says active, but you want to check back in a day or 2 days. And once something has been completed, you'll see it here and you can look at the image. It may not look great, but don't worry about that. Next time, I'll teach you in Afterglow how to adjust the image and make it look good. Okay, let's put the others in. Again, add new observation. The next one on the list is Mars, and it's going to be a low through filter, 1/10 of a second exposure. So let's see where Mars is. You can see it here. Here's the sun. If I move forward in time, so next morning there'll be a little bit of time where it's observable before the sun comes up. Let's see if it's enough. Again, we got minus 12, 20.5. Trying to get my programmer to make that stick. Once you change it, you don't have to keep changing it again. And it looks like it's above the line for multiple sites. There's no guarantee that you have access to all of these sites, but there's so many lines it's hard to figure out which is which, so we're going to just put it in. If it's not taken within 2 weeks, it will automatically unschedule itself. So it's not like you're flooding the system with stuff. So choose filters. My internet kind of crapped out on me here for a second, or UNC's did. There we go. There's low through. Save and continue. We're going to select all available. Save and continue. Pick our generic design telescope, and it was 0.1 exposures. And actually, if you click off of that button, okay, so that's doable by all the telescopes. Okay, 1/10 of a second exposure. Save and continue. And put in the next one. If I'm going too fast, just unmute yourself and ask me to slow down, or if you want to see something again, just speak up. Optical observing. Add a new observation. Next up is Jupiter in the list. Get rid of the advanced settings, and Jupiter is observable at different sites, so we're going to put that in. The planet will only not be observable if it's too close to the sun. I've noticed the UNC internet has been a little flaky since we've all been expelled from campus, so it may be a little slow. Let's see, the flow through is still selected. All telescopes still selected. Save and continue. One 0.1 second exposure. Save and continue. Oh, I know why everything's still selected. I forgot to press the submit button for Mars. Yeah, I have Venus and I have Jupiter. So I forgot to press the submit button. Hopefully you did. Saturn, Uranus, and Neptune to go. So let's add a new observation. Saturn. It's up. Save and choose filters. When my students did this lab at the beginning of the semester, there's like only one planet observable. Everything else was too close to the sun. So this is good. Jupiter's a fun target. Saturn's a fun target. So it's good that as long as we get some data back, we'll have some interesting things to look at. For some reason, it's slow to load the filter page. Not sure why. There we go. Okay, flow through. Save and continue. Select all. Save and continue. And let's see, Saturn. Oh, Saturn is not flow through. My bad. Saturn is the V-band filter. Saturn's fainter, so we want a filter that lets more light through. So I'm going to back up to filters. Instead of flow through, it's down here under Johnson-Cousins, V-band. Okay, so any telescope with the V-band that can observe this target comes up. Again, I'm selecting all. Save and continue. And the lab says 1/10 of a second exposure on our generic telescope. So 1, 0.1. Save and continue. Submit. So far, all of them are observable or close to it. Really kind of impressive. Add new observation. Uranus. Okay, I went straight down to the air mass chart. You can see none of the curves are above the gray line. Uranus is too close to the sun, so we're not going to observe it. Let's try Neptune. -12, 20.5. Neptune is not observable either. Just barely, but not. So we're not going to observe it. So Venus, Mars, Jupiter, and Saturn are the 4 planets that we're going to try to observe. Okay, that's the planets. Got a couple more things here. Moons. We scroll down. So this part, we're trying to image the moons around the gas giants. And we just took pictures of Saturn and Jupiter. But those were filters and exposure times designed to bring out the planet and not necessarily bring out the moon. So we're going to put the observation in again for Jupiter and Saturn with the filter that lets more light through and maybe a different exposure time. And the idea is we may saturate the planet, but it's really going to bring out the moons. The moons are fainter. So these are observations designed to help us with the moons. So Jupiter, again, we search for the planet, minus 1220.5. Jupiter's up, save and choose filters. Before we did Jupiter in a low through, now it wants us to do it in the V-band filter. So I select V.
The high through.
Just V for Jupiter. It'll be high through for the others. Jupiter's still pretty bright. So V and save and continue. Select all. Save and continue. And we want 0.03 second exposure. And you see some of those telescopes have been ruled out. It may be too long of an exposure for Jupiter for these. These are some of our bigger telescopes. It would violate the safety limits of the camera, but the others are still good. These two are shut down anyway because of COVID. Save and continue. Put it in. And actually, I probably should have changed the name of that from Jupiter to Jupiter's moons, just so we can keep track of it. I'll do that for Saturn. That's the last one in this section, because we can't do Uranus and Neptune. So it says Saturn is high through 0.03 seconds. So Saturn, there it is in the sky. So again, this will be in the morning sky. There it is, right before the sun comes up. Looks like we have a Saturn, Mars, and Jupiter are all very close to each other in the sky. So is Pluto, which we'll image in just a little bit. Minus 1220.5. Select filter, and this time for Saturn, not sure why the filter page is so slow. I'm meeting with my programmers after you guys, so I'll mention that to him. Because all the other pages are moving quickly right now. Very odd. Oh, there. Okay, it went through. And in this case, high through. And high through and low through, they aren't single filters. They're collections of filters that let a lot of light through or not a lot of light. So high through, save and continue. Select all. Save and continue. And this one, the lab says 0.03 second exposure. You see, more telescopes have been ruled out. Too bright for those large telescopes. And submit. And actually, I forgot to change the name of this one. I wanted that to be Saturn's moons, but it doesn't matter. We're almost there. 2 more sections to put in observations. Observe dwarf planets, Ceres, Pluto, Haumea, Makemake, and Eris. And in the new version of Lab, I got rid of Eris. It's just so faint, hard to see. So don't worry about submitting for Eris if you don't want to. So these are the dwarf planets. These are objects that aren't big enough to be planets, but they do orbit the sun. They have enough mass to pull themselves into a smooth shape. They just never cleared out their zone. Sirius is in the asteroid belt. These out here in the Kuiper belt out beyond Neptune, no one of them gained dominance, so we don't call them a planet. So Pluto got demoted. Let's put these in next. So let's see, add a new observation. Let's see which of these are observable. I typed in Ceres. And again, we want minus 12, 20, and 0.5. And it is observable. So save and choose filters. And the lab says V band, 3 seconds. The V lets in a decent amount of light. Save and continue. All available telescopes. Save and continue. One exposure for now a full 3 seconds. Again, generic telescope or prompt 5, either of those are actually the same. That'll be our design telescope. Save and continue. Pluto we know is observable because it's close to Jupiter in the sky. So we're going to add an observation. Looking up Pluto this time. Oh, with Pluto we have a couple options. There's an asteroid called Pluto and a planet-moon category object. We want the second one, obviously. And this is where you can change the name if you want to. Whatever you want. Minus 12, 20.5. So Pluto is observable, particularly in our southern hemisphere telescopes, but a little bit at the end of the night for the northern scopes. And for this, it says high through and a full 80-second exposure. So now we're looking at some pretty faint stuff. So all telescopes. One 80-second exposure. You see that knocked out a whole bunch of telescopes because once we scale it, it is some of these are beyond the maximum time for that telescope. And the question is, do we have access, or any of these still online? And this one is. Maybe we scale it back. Let's see if we can make more telescopes active by scaling it back to, yeah, if I go back to 40 seconds, I get a lot more telescopes. Let's see how far up I can push it. No, maybe 45. So you may want to do, although the lab says 80 seconds, you may want to do 40 seconds. It may be a little bit fainter, a little bit harder to see, but we get so many more possible telescopes, we're more likely to get data back. And then we got two more, Haumea and Makemake. Add a new one. Let's see if these are observable. Haumea. Search. Minus 12, 20.5. Oh yeah, very observable. Save and choose filters. High through. Save and continue. All telescopes. And one, and again, if we do 40 seconds, we have more telescope options. Basically, these telescopes that still remain are lower capability telescopes. Higher capability. The lower capability telescopes are getting ruled out. Strange that the prompt ones are ruled out here. Some of them are invoking the bright target limit. Oh, I see the problem. It says here, it just happens to be with Haumea, there's a bright star in the field. And given where Haumea is in the sky right now, there's a bright star, and so Skynet's detected that, and it's ruling out some of the bigger telescopes because that bright star would saturate the camera. So it's not Haumea being the problem, but in this case, it just happens to be near a bright star. Save and continue. Oh, my time account is out of credits. So let me go back and pick a different time account. I ran out of credits. This one has a lot of telescopes. I'll go with that one. Okay. So you get my generic telescope, 1 40-second exposure. Save and continue. If you run out of credits, you're done. But if you guys run out of credits, just let us know and we'll give you more. And then Maki Maki. Take some time to put these in, but then we'll see what comes back. Not sure if it's Maki Maki or Make Make. It's 12, 20.5. Oh yeah, very observable right now. You guys it's fortunate you have lots of targets right now. Most of the time when you run the lab, you don't have this many targets. This one's also a high through. It's fortunate because we have so few telescopes. Hopefully the combination of lots of possible targets and few telescopes will get some stuff back. My design telescope, 140. Let me just check here again, 80. Actually, 80 might be fine. It didn't block out a bunch of telescopes that time. So, maybe try the 80. And if you lose a whole bunch of telescopes, scale back and see. 40, 80, it doesn't matter. It will show. Okay, and then just one last thing, deep sky objects, and these are mostly just for fun. So up here we have a list of star clusters, supernova remnants, star forming regions. Here we have a list of, these are nebulae. So extended diffuse regions. These are star clusters, globular clusters, and these are galaxies. And pick one of each, though if you want to do more, you can. There are Wikipedia links to each of these so you can get an idea. I'll just pick one of each right now. Add a new observation. And these are all mostly southern hemisphere targets. So you're gonna have to find, I think Crab Nebula is farther north. Let me see if that one's available right now. It is at the beginning of the night. So minus 12, 20.5. And so the Crab Nebula, you can see what it looks like here. This is a star that blew up in 1054, the year. And it was so bright, you could see it it was as bright as the moon when it went off. And you could see it during the daytime sky for weeks. So we had this daytime star, which was really cool. A fairly nearby star that blew up. And you can check on its current status. But other ones are interesting too. I like the Tarantula Nebula, and other ones are good too. And these are all high through. Save and continue. All telescopes you have access to. Save and continue. Design telescope, 1 80-second exposure. Maybe I'll scale it back a little bit. I scale it back a little bit more, I get a little bit more telescopes. Well, let's see. It says Crab Nebula. Crab Nebula suggests 80 seconds, but I'm going to scale back because that DSO 14 is still online. So I scaled back because, you know, it's a little. Yep,
Is
go
this
ahead.
the homework?
Yep, this is the homework.
This going to get graded?
Yes. And that's my understanding. I'm not your teacher. I'm just here to help you navigate the system. But
Yeah, I will post this video online, so you just follow, okay?
So wait,
even you made a small mistake, that'll be fine. So the
Well,
important thing is
how much is it if we don't do it?
you just submit, you just follow, that's it, okay?
No,
But
if we don't do it, how much is it worth off our grade?
if you don't want to do that, if you still watch the video, but I still give you partial credits. But this is just follow. Even you submit a 1,
so wait,
I still give you credit.
you telling me all we had to do was just observe, like ask for the images and get them back, and that's it?
Yeah,
Because then we're going to Afterglow and change
when
them.
the image come back, you do the analysis, that's it.
Yeah, we'll do the analysis for next week, but for this one, you just want us to go through and get the pictures and
Yes,
receive them.
yes,
So that
exactly.
way
Just
next
submit,
week-
that's it. Even
Okay.
you submit a several, not necessary to 100%, I still give you credit.
Okay, see, I was misunderstanding because I was assuming that once we had got the pictures, we were going to have questions on what we had done for this week. I didn't know that like most of our work was going to be happening next week. That was misunderstanding.
Yeah. So the purpose for this lab is how to use the remote control the telescope, submit your job, and then with the image come back to a little bit of analysis. That's it. So as Professor Richard said, maybe I only count this. Okay, the whole semester, the whole the rest of 3 or 4 weeks. Just focus on that. And I will post this video as soon as possible online. You just follow. Okay, even made a mistake, you submit a mistake, I still give you credit.
Okay, cool.
Okay.
Yep, and that's why I've been going through every single one because I assume you're following along at home and putting the observations in. If you're just watching me, I'm sure you're incredibly bored now, me doing the same thing over and over again. But I'm assuming that you're doing it at home as we're recording this, and so by the time we get through this, all your observations are submitted, and then hopefully some of them will come back by next week. And yeah, it's a pretty cool thing. This is professional quality telescopes scattered around the world. It's rare to have access to this kind of system, so I hope in the end this is a enjoyable experience for you. It's not, you could be given an ordinary homework, calculate these 10 things and submit it. This is something totally different, unique, fun. It's what the pros do, and you have access to the system. So I hope you enjoy doing it in the end. But the first step is a little tedious. You got to put all the observations in. And, maybe I won't show the last 2, but I demonstrated how to do it for a nebula, and also just pick a glob and a galaxy. And then that's it. That's all the observations that go in. And we'll see what comes back next week. And I'll show you how to use the new version of Afterglow. The links in the lab are for the old version, but we're going to be using the new version. And then it's not just, it's cool just to get the pictures back. Like, I did this. I took this picture myself. But then we'll try to extract some information, do some science with these. So any questions?
Yeah, I will post the PDF file for new Afterglow software online also, and I will post this video link as soon as possible. And then you just follow. And as I mentioned that if you do something, I give you credit. So don't worry about that.
Yeah, this is the first time we're doing it at Winston-Salem, and about a dozen other institutions do the labs. Some do all of them, some do some of them, but this is the first time through. So and it's the first time through using Afterglow 2. No one else has moved to Afterglow 2 yet. So you're forging new ground for us, and we're really interested to see how well it works with you. We're hoping to do this live face-to-face. Instead, we're trying to do this over the internet, but it should work over the internet, and we'll just see how it goes. All right, so if there are no other questions, I'll stop the video. I'll send the recording link over to Professor Zhang, and he'll send that and the PDF of the updated lab to everyone. And for those who are not here but will be watching the video, do not delay. Definitely put these observations in today when you get this video, or the next day, but no later than that, because again, we're down to a very small number of telescopes. The weather can be bad for days on end. So the sooner you get it in, the more likely you are to get images back before next week. If you wait till a day or 2 days or 3 days before, you may not have anything when we go do our work with Afterglow. All right.
And also I will extend the deadline. And if we don't have enough time to do that, maybe only we focus on the lab number 1, that's it.
Yeah, we'll keep working on this until it's good, right? Until everyone, and most everyone has gotten some stuff and is having a good time with it.
Yeah, thank you so much.
All right, see y'all. I'll be back
Let's say next Tuesday, right? Let's set up a next Tuesday at the same time.
next Thursday, same time. Yep. And
Okay.
I'll send that link. I'll set that up right now. We may have a small number of students because I didn't get you the link until yesterday. I'll send you the link and the video and the PDF again, all in one email.
Sure, thank you so much.
Okay.
Bye-bye.
See ya.
See you, bye.